First of all, good morning to all of you. Today, I have started the group problem solving. In this group problem solving, here in this figure, you can see that a baseball which is pitching the machine, a baseball pitching machine, okay, which is normally throw the ball with the horizontal velocity of v0. Now if you want the height h to be 42, determine the velocity of that ball. So this is the one modified, we can say modified form of the projectile motion problem, right? Here you can see that the length between this man and this punching ball machine is 40 feet, and here they given that this height from the ground to punching machine, this um, ejection time distance, that is the 5 feet, and you have to find out that the h, right? And that is if it is to be 42-inch, it said. Okay, so to solve this type of problem, first we have to understand what are the data we have. So first of all, that is the distance that is along x direction. So we can say this is along x, it is 40 feet, and y0, it is 5 feet, which is in this figure you can see here, this one. Next, the yf means from the man side, this h is a 42. So you have to find the velocity so that it maintain its height. So you all know that the y is equal to, means s is equal to ut plus half of at square. You all know about that, na? But for the present scenario, as it is a gravitational acceleration is come into this picture, and as it is comes to the downward direction, so we can say this is a formula in the modified form is ut uv is equal, u means here the y0, which is 5 feet, ut minus half of gt square. Okay, now 3.5 you all know is this one. This one is 5. So initial velocity is 0 and the half of gt square. So we put this value and we can simply get that it will take this amount of time. Now, if you analyze the momentum, you know the distance and the velocity relationship, that is the s is equal to vt, right? So here just along the x direction, so x is equal to u plus vt. So here it is 0 initially. So the vx, which is here, is given as a, means we have to find out, and x is here 40. So 40 divided by that time. So we can easily find out that if our initial velocity v0 is 131.047 feet per second, then we can easily find out, or we can easily maintain this to height. That means this is 5 feet, which is in terms of inches. How many inch? 5 feet is equal to 5 feet is equal to how much inch? Hello? 5 feet is equal to how much inch?
16, sir.
Yes, 60 inch. And here it is given that h is equal to 42 inch. So 42 inch means in terms of height, it in terms of feet, how much it is? 42. Very simple, na? 3 feet and 3.5 feet we can say. No? 3 feet 6 inch. So 3.5. So it means that when that baseball will will start its motion from this point A, it have a certain velocity we have to find out. And as per the question, we have to maintain that height here and here. Here should be 3.5 feet, here should be 5 feet, and the distance it is maintained as a 40 feet. So find out the initial velocity. That is a simple problem. Okay. Now come to, so up to this you all are aware about the rectilinear motion, then the projectile motion. Now come to the another means this is come under the similar to the rectilinear curvilinear motion. You all know here in this picture you can see in the Formula 1 car, if they have the track, if you see there is have a curve in the path. In the train also sometime you can see the curve path. So this type of path, how to find out the velocity and the acceleration, as we are dealing with the dynamics part. So we are basically bothered about the velocity and the acceleration of any particle, right? And here this is the for any curvilinear, in any curvilinear motion we have to find out that one also, means the acceleration and the velocity. Basic motto is that. Now how to find out that thing? See, here two things are there. In the curvilinear motion, we can divide two component, that is one is tangential component, one is the normal component. In the tangential component, you can see in this figure that if a particle have certain velocity and it moves through this path, then the tangent of that path at any time, we can say, means at this point, at this point, this point, here, any place, if you make the tangent, it will always give you the velocity of that particle. Okay. Now if it is the velocity, then for to formulate, how to formulate this thing, that is the velocity, one is 2 unit, we can say. Sorry, 2 unit. One is the tangent in the tangential direction and the normal direction. And the tangential direction, it is denoted as a et term in this red color, I think you can see. And in this normal direction of that particle, always it gives the e term, acceleration term. Okay. I think you all know that acceleration, which means the derivative of the velocity, time derivative, right? So remember that is always given the in a rectilinear motion the acceleration, na? But here if we, and the in the rectilinear motion, the acceleration which we have already found out, that is the direction of the velocity also. Similarly, here the direction of the velocity, in this direction, if we find out the acceleration, that is always the tangential acceleration velocity, tangential acceleration term. And that is here you can see in this figure that tangential velocity is v, and the derivative term of that is the tangential acceleration, and it is a et. Okay, this portion along this direction, it is the direction, and en also the direction, it indicates that the normal direction, it indicates the tangential direction. But if in question sometime it is asked that along the curvilinear motion, if a particle move, find out the acceleration which is along the normal direction. So then which one you have to find out? Can anyone tell me? Along the normal direction, the acceleration, which one? What is the formula for the normal direction acceleration? Hello? See, in this acceleration, here you can see, I think, that this one shows you the velocity direction, also the acceleration direction. The acceleration component along the velocity direction is this one, dv by dt. But if they have the two component, when there is a curvilinear in a curve, in a curvilinear motion, so there have another normal component. So that normal component velocity acceleration is which one? That velocity square divided by the radius, so where it is denoted as a rho. Okay, so if in the question sometime asked that find out the acceleration component along the normal direction, so for that don't use the dv by dt, for that always use the v square by radius of that curve. Okay, now one problem we can solve that here in this problem you can see that a car which travel and it goes in this direction. Now the radius of this curve is 2500, and if the motorist is traveling on a curved section which have at a speed of 60 mile per hour, and the motorist suddenly applied the brake and causing the automobile to slow down at a constant rate. Remember, some terminology in a question is very important. Okay, so knowing that after 8 seconds the speed has to be reduced to 45 mile per hour. See, previously it was 60 mile per hour. After applying the brake, it will comes to the 45 mile per hour within the 8 second. Na? So determine the acceleration of the automobile, or better we can say deceleration, because it reduces its velocity after brake have applied. So that is the question. So to solve this type of problem, what we have to do? Simply see, first, we have to convert all mile per hour into the feet per second. Remember, sometime in question, if ask this type of problem, first convert that one. And the technique is always remember 60 into mile to feet is the 5280. Remember this value. In exam, it is very essential to solve some numerical problem. So 5280 feet and divide by the hour to second 3600. So you will get that 60 mile per hour is equivalent to the 66 feet per second. Okay, sorry, 88 feet per second. And when it decelerates, that is the 45 mile per hour. So you will get that 45 into 5280 divided by 3600, which is nothing but the 66 feet per second. Okay, now the deceleration, as per the question, they said it is constant, right, at a constant rate. So constant rate means, remember, I have told you that the average velocity and the average acceleration concept means with a long time span they will show us the same magnitude of velocity or acceleration. Okay, so here average acceleration is dv by dt, and dv is how much? dv is initial velocity minus final velocity. Initially it was 88 feet per second, which means the 60 mile per hour, minus 66 feet per second means the 45 mile per hour, and within the time span of 8 seconds. So it means our deceleration rate is 66 minus 88 by 8, so minus 2.75 feet per second. So up to this we can easily understand. Now there have a two part. I told that any acceleration of any component, remember in exam most of the student wrong their answer, only they write down that 2.75 feet per second square, this is the answer. But remember, for any curvilinear motion, this is not the final results of acceleration. Remember this thing, this is only tangential component of the acceleration, which is equivalent to if a car travel along the straight line, same acceleration will come into the picture. But here the car is not in the straight path, it is on the curve path. So another acceleration will come into picture, that is called the acceleration into the normal direction. Okay, so the normal direction, what should be the acceleration? That is always the v square by radius of that path. So here it is 88 feet per second divided by 2500 is the radius of that path, right? So you can easily get the acceleration along the normal direction, which is 3.10, sorry, 3.10 feet per second square. So the total acceleration which will be the square root of along the normal direction and along the tangential direction, both square. So finally you will get 4. Here you can see now, that's 2.75 square plus 3.10 square is 4.14. So this is your final answer. Remember this thing, don't confuse. When the car, I repeat again, when the car move along the straight line, if they find, if in the question it is asked like that, you have to find the acceleration, means for the present case is the deceleration. So only up to this one, okay, that is a 2.75. But when in the question is like that, it is the motor vehicle move along the curve or any curve path, then always remember you have to also find out the normal component of acceleration, and finally just square up of both and you will find out the final result. Okay, now another question in the another question which has been asked, that is, if these two components, that is the normal and the tangential, how much angle it will create between these two angle? So that is nothing but the simple form, that is the tan alpha, and the tan alpha, you know, normal divided by tangential, right? Here in this figure you can see this is your alpha. Always remember, this is not your alpha, this one is your always alpha. Alpha means the angle which is always create an angle with respect to its tangential component. Remember this one, not the normal component. So you will get an by at, and this is 48.4 for the present question or present problem. So at this angle, at an angle alpha is equal to 48.5, your acceleration will act on this body or on this motor vehicle. Anyone have any question up to this? In this problem, regarding this problem, anyone have any confusion or any question? Hello? Hello? Anyone have any question? Okay, I just move forward. So see, up to this I think everything is okay. Now another solution, we can say that the tangential acceleration of the centrifuge cab, which is suppose given as a at means the tangential, along the tangential direction, the acceleration component, right? Where t is in second and at is in meter per second square. If the centrifuge start from first, determine the total acceleration. Here also they ask the total acceleration in terms of the magnitude of the cab after 10 second. Okay, so to solve this type of problem, Please, student, if my voice is audible, then please send your attendance screenshot. Okay, please send your attendance screenshot. So what happened? So here, first what we have to do, the procedure is first identify the coordinate system and then calculate the tangential velocity and the tangential acceleration, then also calculate the normal acceleration. Okay. So this is the problem for yours. If we just show you that you have a centrifuge cap which have a arm of length is 8 meter, and the for our present problem it is the just radius of our circle. Okay, right? Now if it is move in such a manner that the tangential velocity always perpendicular, or sorry, always tangent to that arc or path, and the normal direction is always towards the center na. Now, or for in the case of circle only, if this is a arc, then not always it is the center. Now, first of all, you have to find out the tangential velocity. So tangential velocity, you can see it is given in this question 0.5 t na. Here you can see it is given in the question. So the velocity, tangential velocity term, if we need to find out, then how to solve that? The tangential velocity term, just integrate that equation which is given in the question. So if we only integrate that term at, then we get the vt, and integrate of 0.5 t, and the this is a closed form equation, or we can say this is the closed integral. So it means they have of some value of t, that is 0 to how much? In as per the question it is given how much time after 10 second na. Here you can see after 10 second find out the total acceleration. So see, 0 to t, zero point 0.5 t of dt, so 0.5 t square by 2, which is a 0.25 of t square, and 0 to t is 10, so 10 square we will finally get 25 meter per second. So it means when these centrifuge move or start its rotation, then after 10 second the tangential velocity is the 25 meter per second. And similarly, if you find the normal acceleration, that is the velocity square by radius, velocity is 25 square, radius is 8, so it will give you the 78.125 meter per square. Then final acceleration is the both the normal acceleration and the tangential acceleration, their square root, right? And you will finally get it is 7. Oh, remember at is the 25. Here it is given na, zero point 0.5 into 80 is how much? 80 is zero point 0.5 of t, so zero point 0.5 and t is 10, so both square. Okay, so finally we'll get 78.285. So this is your final acceleration of that centrifuge after 10 second of rotation. Okay, where it is. Okay, now, see, previous one is the tangential and the normal component, which is we can say applicable for any curve path. Now, there have the another technique or coordinate system, we can say, that is the radial and the transverse system, coordinate system or components. So here what happened? See, by knowing the distance to the aircraft and the angle of the radar, air traffic controller can track the aircraft. Okay, and here in this truck you can see here this one, the fire truck ladder can rotate as well as extend, na? Means it can move along a circular motion as well as it can extend, right? So the motion of the end of the ladder, means this portion, can be analyzed using the radial and the transverse component. This is the another coordinate system. Okay, student, please send your attendance screenshot. So in this radial and transverse coordinate system, how we can define? We can easily define this thing that here in this radial and transverse component, you can see if this is your starting point and if a particle have a position vector that is r, we can say, right, from this is a coordinate system 0 0 0, this is the position vector of that particle which moves along the curved path. So here the direction is the r is equal to r e r. Here this r is the vector, this r is the magnitude of that length, means this one, this blue ray or arrow we can say. So this length is indicates by this r. Okay, and the er is the unit vector, better we can say, along this direction. Now the question is, for the application we have already discussed, that is for which case we can apply or we can use this thing, right? So the normal component here, that is the, or we can say better, it is a radial component, that is the e r, and the transverse component, that is the e theta. Okay, now the transverse direction, always remember this have a 90 degree between these two, this is always 90 degree, remember this thing. Okay, so that vector, the position vector better we can say of that particle, which is r dot er, and er is the unit vector of in that direction. Now the particle velocity vector, if we need to find out, you remember this, you have to remember this formula, that is v is equal to r dot er and r theta dot e theta. This is the formula you have to remember for finding out particle velocity vector for the radial and transverse component. And the particle acceleration is a is equal to r double dot minus r theta dot square er plus r theta dot, sorry, r theta double dot plus 2 r dot theta dot e theta. This also you have to remember for the, to solve any problem which may come into the exam. Remember this thing. Okay, for the derivation it is also available in the book, which book already I have sent to all of you, that is the Beer and Johnson. If in that book anyone find any problem in understand, then you can ask me. This is a very simple thing. Okay, now uh, remember, as this is a little bit tricky, problems are based on this type of formula we can provide, so it is better I solve some more problem on this so that you are easily solve this type of problem. Okay, see, okay, so next, see, This is a sample problem, we can say, that is related to the your radial and transverse components. Here you can see, student, if my voice is audible, please send your attendance screenshot. Send your attendance screenshot to me. So in this numerical problem, which is visible here, here see, this is rotation of the arm. This is an arm actually, O A, and it will rotate, okay, by an angle of theta is equal to atto, which is 0.15 t square, and the collar, which is here, it is B, it is a collar. It is actually when OA rotate, or we can say it will in the circular motion OA, then this B will move along this straight line or along this arm, okay, means it can move along in this towards the radius or towards the center O, and it can move from the center O, okay, in such a manner only it can glide actually, slide here. So the collar B which slide along the arm, that have R is equal to 0.9 minus 12 t square, where R is in meter. Okay, so the question is, after the arm has rotated through 30 degree, if, then determine the total velocity of the collar A, that is the first problem. Next problem is the total acceleration of the collar, and C, the relative acceleration of the collar. Okay, so this thing you have to find out. So to solve this type of problem, first what we have to do, evaluate the time t, means the time required to rotate for an angle of 30 degree. So that is the first case. The second case is, evaluate the radial and the angular position and first and the second derivative of the time. Okay, so these two things you have to, this is actually the step to solve this type of problem. Hmm. Okay, so as per the question, you can see theta is equal to 0.15 t square, it is given. So 0.15 t square, if we solve this problem, theta is equal to 30 degree, then this is nothing but the t is equal to 1.89, sorry, 869 second, right? Just put the theta is equal to 30 degree and find out the time for that. Now, the radial direction, evaluate the radial and angular position. If we say, then R is equal to how much? R is equal to, in the question it is given, that is 0.9, where it is, that is 0.9 minus 0.12 t square, that is the R. R means this length in terms of equation they provide as per the question. So to solve it, first put the time value here 1.869, and you will get this amount of distance for R, means this length, right? Now do the R dot, means the derivative of that equation, which we can easily find out. So that is 0.12 t square, derivative is 2t, so 0.24 of t, and t is 1.869. It will give you the R dot is equal to 0.449, and R double dot, that is the acceleration, right, along the radial direction, which is the 0.24. Why? Because the only derivative again the with respect to time. So you will get this one. Similarly, theta, if you need to find out the theta dot and theta double dot, as per the equation, means formula, it is needed, right? Here the formula is r double dot minus r theta dot er and the r theta double dot plus 2r dot theta dot. So this is your formula. So let's solve this one. Now put this value only. See here theta is 0.15 t square, only one time derivative, zero point 0.3, then again derivative 0.3 rate per second square. Now and put the value for theta dot, zero point 0.3 into time is 1.896, you will get this one. Similarly for theta, just put this value of time, you will get the theta is equal to this amount of radian. Now if you calculate the velocity and the acceleration, then to solve this one, what you have to do, just put the vr, which is the r dot, you already find out this value. Then the v theta is how much? V theta is the r theta dot, right? So r theta dot is 0.489 is r and theta dot is 0.561. Here you can see na, this one is 561 na. So and our final velocity, as I told you, for the tangential and the normal sorry, for the radial and transverse component, the velocity is the nothing but the r dot er plus r theta dot e theta. So the velocity, which final velocity or the total velocity, is the root over of vr square plus v theta square. So you will get 0.449 square plus 0.27 square, which is finally give us this value 0.524. Here the acceleration is also ar er plus a theta e theta, and the ar component here in this figure na, you can see in this equation ar is nothing but the r double dot minus r theta dot square. So put their value, respective value here, and similarly find out the a theta by putting their respective value and the total acceleration. Here you can see in this figure that acceleration one is minus 0.39, which indicates the direction towards the center, and the acceleration of a theta minus 359 also indicates the towards the center. So in such manner, because normally we what we have to do, normally along this direction it is positive and along upward direction it is positive. So as this value is minus, so that's why you put the an arrow in this downward direction. And the angle between two components of acceleration, that is the radial and the transverse, that is the gamma, denoted as 42 degree, and I told you always it is come with the tangential, and for the present case that velocity direction and the acceleration direction are same for the case of r, right, ar. So that's why this creates an angle of gamma. Okay, so finally we get the total acceleration by squaring up of both, so it will give us the 0.531. Okay, so this is the another problem which we have solved. Now, if in the question they ask that the evaluate the acceleration with respect to arm, means when this arm OA rotate, that time this collar move along the arm. So what is the relative acceleration then? So that relative acceleration is only the along the radial direction, which is nothing but the ar. Okay, so it means, see, this component only, ar, only this component, relative means only this bone, sorry, only this collar movement, only collar movement. So only collar movement is the along this OA path, so that is the r double dot only. Remember this thing, only r double dot they need to find out. So that's why it is the minus 240, and that will come into the picture here. See, minus 240. Only in this direction the acceleration is how much, we have to write out only that one. Okay, for the only color case. And you may ask then, sir, where from, means for which case we apply the r theta dot square. this r theta dot square actually we have to put when that arm is in the question. As per the question, the arm is also rotate, right? So as arm is also rotate, so for that this component will come r theta dot square. Okay, so regarding this, any question, anyone have any question regarding this matter? Okay, so I end my lecture here. Thank you to all.